Hi guys, today I'll be trying LeetCode 98, which is validate binary search tree. So it's a very simple problem. Given the root of a BST, we have to determine if it's a valid BST or not. So there are basically three conditions for any BST to be valid. We have to have that the left subtree of a node contains only nodes whose keys or whose values are less than the node's key. And similarly, the right subtree of a node contains only those nodes whose values or whose keys are greater than the node's key. And obviously, the left and right subtree should always be BST themselves, and they should be recursive until we reach the leaf nodes on both sides. So if we have the first example, we see that the node is 2, the root node is 2, the left subtree or the left node to that uh, root node is 1. So that's lesser than 2, which is valid because it's a left subtree of that entire tree. And 3 is similarly the right subtree of that entire tree. And 2 is less than 3. So it satisfies both our conditions, and therefore we output true in this case. In the next example, we see that the left subtree of 5 or left node of 5 is 1, which is true, which is valid, and the right subtree in this case is 4, which is not valid because the right subtree's first value in this case, or any value in the right subtree, should be more than that of the root. Because if we remove everything else except for the right subtree, we should still have a BST in place, which is not true in this case because we will have that 4 is a value which is less than 5, which is supposed to be more than 5 because it's in the right subtree. So we return false. We have that the number of nodes and the range 1 to 10 to the power 4, and technically it's from negative infinity to positive infinity, or negative the range of integers to positive the range of integers. So we'll make sure we consider our nodes in those ranges, and we'll code a solution accordingly. So now what we have here is that we could define a helper method within this which checks if it's valid or not. So we define a valid method. So we define valid, we take in node. Okay. Now we perform our checks. First check is if we don't have a node. So if not node, if that is true, we return true, right? Because in this case, we don't have anything to compare with or check if it's less or more than. So we return true because it's empty. It's the base case in some sense. Now we check for our conditions. If dot val is less than right, say node dot val is greater than left. So if we have these two conditions, or if we don't have these two conditions, then we return false. And when these two conditions are done, we have the only condition left where it's a valid BST in some sense, right? Because we've checked both our conditions. So recursively call the valid method. Node should be node.left. We check the left node of the tree. The left bound remains the same, and we compare that with the next value in the tree, which should be lesser. So which we have node.val, and we also have that for this. We also have the same check for the right subtree. So we do valid dot right. Our left boundary in this case is the current node we're on because we're checking if it's greater than the value. So we have node.val, and then we have right. We return that value, right? Whatever we obtain from that. Now we return at the end call to valid, which would give us these parameters are extreme values for left and right subtrees. So we can do this. Go to minus infinity, as I mentioned earlier, float to positive infinity. Okay, so we have this. This should be fine, I guess. I'll try and run this and see if it works because our conditions were satisfied, right? It works, and if we submit this, we get that Accepted 52 milliseconds, around 17 MB of memory, and it's all right. We have made our checks and conditions here, and I think this should be sufficient. So thank you for watching, and I'll see you in the next one. Bye bye.